Hey guys, this is another MATHCOUNTS problem. So we have a absolute value equation. Okay, we are given in a square units what's the area of the region bounded by this graph. So there are maybe like some tedious way to approach, which like you can use the definition of absolute value. You can just look into regions for the x and y is like negative and positive, or where the x is larger than y, or the other way around. You can just kind of go with those cases, but it's kind of too tedious, so which is why I don't want to really try that way. So I'll try something else. So we have a absolute value plus another absolute value is equal to 6. Maybe we can kind of make our life a bit easier by plugging some easy values, okay, to get at least some sort of idea about what kind of figure we are trying to see, okay? So what I'm gonna do, if I have this guy like x minus y, okay, the absolute value of the x minus y, actually, if this guy is equal to 0, then the absolute value of x plus y should be 6, right? So if the result is 0, that means x minus y has to be 0, which is like x is y. Okay, so again, we want to satisfy the second as well. So if the sum is 6, so you could have two ways. Either the sum is 6 or negative 6, because you take the absolute value. So from there, you can say x and y could be 3 or negative 3, because if you add them, you got negative 6. The absolute value will be 6. So we have two different values. So let me use this to graph my kind of figures. So since I don't really know for now how that will look like, but I do know at least some points for now, okay? So if I choose x and y is 3, so it will be, let's say, something right there. So 2, 3. Okay, so this is 1 point that will be for sure on my region. Okay, on the vertex, I would say. And then we have negative 3 and negative 3. So it will be 1, 2, 3, 1, 2, and 3. So you will get something right there as well. Okay, we have at least 2 points. So if this guy was 0, and this could be 6, right? That was maybe case 1 I can maybe take a look at. And maybe another one I can take a look at is like, maybe this guy is 0, then this guy is actually 6, or maybe some other ways, okay? So from maybe there, I'll try that as well. So x minus y, if this guy is equal to 6, while x plus y in absolute value is equal to 0. If the result is 0, which means only way that will be 0 inside has to be 0, which means x plus y equals 0, so x has to be minus y. So let's plug this into this guy. So that should be x minus y, right? So let me take this one. Instead of x, I can replace with minus y. So minus y and minus y. So that is the equal to 0. If the result is 6, so I mean 6, so you could have inside 6 or negative 6. So negative 2y, either 6 or negative 2y will be minus 6, right? So from there, so you got negative 3 and you got just 3. So again, when x is a negative version of y, so we have these two, which means x has to be 3 while negative y is negative 3. That's another point. And x has to be negative 3 while y is 3. So let's plug these as well. So 3, negative 3. So this was 3 and this is negative 3. So we have another point. And then negative 3 and 3, it's going to be right here. So from here, as you say, like if you don't really have much time, you can assume your figure will be a square, and you can actually go from there, okay? And then that will be like 6 units. That's 6 by 6, which is going to be 36. And you can go with this. But if you do have more time, it's better to actually confirm that it is actually a square, maybe by plugging more points or some other like numbers value. And we just kind of try 2 different ways, right? And maybe if I start with something else, like what I mean by that. So if you do have, like we did, if this guy is 0 and this guy will be 6, or the other way around. But what else do we have, right? So we might have maybe some like otherwise, like maybe both are going to be equal to each other. So let's try that as well. Even though we don't really need it probably, but let's say x minus y is equal to 3, while x plus y is also 3. So then you can take a look at what values are going to actually going to be given these same result. So since we have x minus y, it could be 3, and x plus y could be 3, but if you add them, you got 6. The y's will cancel, so the y 2x will be 6, x should be 3. We already kind of got that, right? So if x is 3, then y was 0, which is actually we didn't get that. So yeah, we could have this another point. So again, I said if the inside is positive 3 and inside is positive 3, so we have these two cases. And when you add them, so you do add 2x is 6 and x is 3. If x is 3, so y has to be 0. So 3 comma 0 is just another point, which is right there. And maybe the other way around, right? So maybe x minus y is 3, but maybe x plus y is minus 3, right? If you add them, so your y's will cancel, these will cancel. So you got 2x is 0, x is going to be 0. And if x is 0, then y has to be negative 3, right? So 0, negative 3. So this is 0 and negative 3. As you see, we got this point, we got this point. So which is actually proving that my graph will complete a square. So if I continue to input more points, I will get some other points on these lines. And my actual figure will be a really nice square. Okay, it will be something like this. Again, if you do have more time, you can plug more points and just to see how that looks like. And that will be what we are gonna get. I hope that makes sense. And if you find some other ways, maybe better than this one, so let me know and I'll see you in the next video.